So what we have is a proof, okay? And it's a double angle proof. So when you see double angle proof, what you want to refer to is the single angle where you have a starting off basis of another equation, okay? So here's the equation that we're familiar with. Now, what we're going to do next is we're going to replace, see the way it's 2 theta. So if I replace A and B both with theta, so say A equals theta and B equals theta, then we can figure out that they both have theta involved here. So it's going to be cos 2 theta equals cos theta by cos theta. So it's going to be cos theta multiplied by cos theta minus sine theta sine theta. Now we're going to multiply cos theta by cos theta to get cos squared theta, and then we're going to have sine theta by sine theta to get sine squared theta. Now, what we're going to notice next is that we have no cos squared thetas in our answer. So that brings us back to the following formula. It brings us back to a formula you can see on page 14 of your tables. Cos squared theta plus sine squared theta equals 1. And what we do is we isolate sine squared theta by bringing over, we isolate cos squared theta by bringing over sine squared theta. So it's going to be cos squared theta equals 1 minus sine squared theta. Now, it's the cos squared theta above, you're going to replace that with 1 minus sine squared theta. So it's going to be cos 2 theta equals cos squared theta minus, where's my brain going? Replace cos squared theta with 1 minus sine squared theta. That's that part here, which I'm circling now. And then you just get minus another sine squared theta. And lo and behold, it's going to be 1 minus 2 sine squared theta. And that is your proof for that question. So find the cosine of the acute angle between two diagonals of a cube. So if you imagine a cube, this is like the top left corner, and then you're linking it to the back corner. And then you have another side, which is the bottom left part of the front face, will link at the top right of the back face. So we're sort of going a diagonal all the way across the cube. Now this question looks very complicated, but what we have to remember is we're only allowed to deal with 2D triangles. We only have laws for 2 dimensions. So what I'm picturing this like is a bit like an envelope, okay? So if I put a square like that, this is the envelope I'm picturing right here. So I'm just going to grab this envelope and just copy and paste it over here. Okay, so that's the envelope I'm picturing. Okay, and okay, so that's pretty much what I'm picturing there. Now I might actually just do my own picture of it because that didn't turn out as I suppose you'd be forced to do this in the test anyway, so why not do it here? Okay, so what we're picturing is our two sides like so, and as stated above, that's red, red, and that's blue, blue. Now, what I'm going to do is I'm going to call a standard side of the cube, I'm going to call that standard side x. Any length of the cube in any direction is x. So that means you're an x and you're an x. All right. Now, what I'm going to look at next is I'm going to pick two sides to have a go at here. I'm going to first of all pick this yellow side here. I'd love to know what these two yellow sides are. So this yellow side is actually this length here, and it's part of a right angle triangle system. So you can see that it's actually part of a right angle triangle system. Sorry, that's an isosceles triangle. Let me do this more precise. Okay, there you go. And it has x and x here. So you can see this right angle triangle system just shading in here. That's x here and x here. For argument's sake, we'll call this d. So d squared equals x squared plus x squared. D squared equals 2x squared. D equals, now what I'm trying to remind you guys is, if I was to ask you the square root, I'm trying to think of a good number here, the square root. If I ask you the square root 9 multiplied by 4, which is 36, and I said x squared equals 36, you'd all tell me x equals 6, just square root it. Now, if I said x squared equals 9 and 4, 9 multiplied by 4, you could square root both the 9 and the 4 individually, and you can get 3 times 2, which is 6. So what I'm going to do is I'm going to square root the 2, and I'm going to square root the x squared. So root 2 stays as root 2, and when you square root x squared, what happens is the square disappears. So it's going to be root 2x. So that there is root 2x. Okay, that's your basic mechanics right there. Now, I have two sides ready to go. Now, what I'm going to look at next, I'm just going to keep rubbing this stuff out here. I'm going to look at this flat triangle here. You'll see me highlight this in a second. So what we're going to do is we're going to highlight this. See this red triangle I'm looking at here? See the way it's flat? It's basically half of my envelope. I think we could work with that one. Yeah. And what we can do is we can get this full length here. This full red length here would be a good idea. So once again, we're going to do Pythagoras' theorem. You're going to have to use a different letter. You're going to call this length L. So L squared equals x squared plus root 2x squared. L squared equals x squared root 2 multiplied by root 2. So it's root 2x multiplied by another root 2x. The x's combined to make x squared. The root 2's combined to make 2. So that's 2x squared. And then we're going to get L squared equals 3x squared. Cool. Alrighty then. So that is that done. 3x squared, and that's. Now we have to square root that. And we do what we did last time. Square root the 3 to get root 3. It's going to be root 3x. Now, in order to get this angle here, and it specifically says the cosine of the angle, I'm thinking the cosine rule. Now, if I'm taking the cosine rule and I need an angle that's in between, that means I need to know all 3 lengths of the triangle. Okay. Now, in order to get all 3 lengths, we know that this one is x, and we know that this one, we don't know this green length here, but what we do know is it's half of L, so it'll be L over 2. And what we can do then is we can find out what angle A is using the cosine rule, is what we're hoping. So half of L is going to be root 3 over 2x. And that's going to be another root 3 over 2x. And it specifically says cosine. It doesn't say find the angle. It says find the cosine of the angle. I'll explain what that means in a minute. So we're going to grab all this here. Going to group it. I'm going to bring it down and we're going to work on this part. And as you can see, this was a very difficult question that year. This is part 4, and it's quite challenging even how to start this. Just about trying to accumulate information to get good marks. Now we're going to do the cosine rule, where a squared equals b squared plus c squared minus 2bc cos a. That's a minus, not a plus. Now you might say, why am I doing the cosine rule? Well, I need to find the cos of an angle. There's the cos of the angle. And I only know the length of the 3 sides. And you would have learned from more basic examples is that if you have three lengths, and for argument's sake, the 3 lengths, and you want to find an angle, 3 lengths, no angles, and you want to find an angle, it's the cosine rule all day long. So, okay, one second. Okay, so what we're going to do here is we're going to have opposite capital A is small a, so opposite my angle A is x, so it's going to be x squared equals, it's going to be root 3 over 2x to be squared, because that's, we can call that B and C, these two sides. Minus 2 times root 3 over 2 x by another root 3 over 2 x cos A. Now, What's root 3 over 2 multiplied by another root 3 over 2, x? The x is multiplied to make x squared. The 2 multiplies by 2 to make a 4. And root 3 multiplies by root 3 to make 3. So quite simply, it's 3 over 4 x squared plus another 3 over 4 x squared. Now, root 3 by root 3 is 3. 2 times 3 is 6. 2 times 2 is 4. 6 over 4, which is the same thing as 3 over 2. X squared cos A. Now, we're going to move everything over to one side. Now, you notice that everything has an x squared in it. Everything has an x squared. So, we can get rid of the x squareds, and we can turn it quite simply into this. The x squareds aren't causing the balance. So, for example, is if I said 5 apples plus 2 apples equals 7 apples. The fact that they're apples isn't causing the balance. It's how much of them there is. So it's 2 plus 5 plus 2 is 7. It maintains the balance. So we're dividing both sides by x squared to get rid of the x squareds. So it's going to be 1 take away 3 quarters, take away another 3 quarters equals minus 3 over 2 cos A. So we're going to do 1 take away 3 quarters, take away another 3 quarters. What we're going to get is minus a half. So we're going to get minus a half equals minus 3 over 2 cos A. Both sides are minus, which means I can make them plus. Both sides are divided by a half, so the half doesn't matter. So if you want, multiply both sides by 2, multiply both sides by minus 2. And what will happen is you're going to get 1 equals 3 cos A. And then you're going to get cos A equals 1 over 3 because the 3 divides underneath. And you're done.